Hello there! Welcome back to science class for some more notes on fronts. What is a front? Well, the front is where two air masses collide. We're talking about air masses, we talked about polar, continental, maritime, tropical. Air masses have different densities. Cool air having one, warm air having another. So a narrow region between two masses with those density difference is what we know to be a front. All fronts are classified by the types of air mass that is replacing. So if there's a warm and a cold and the cold one's replacing, it's going to be cold. If there's warm and a cold and the warm is doing the replacing, it's going to be called a warm front. So for a cold front, we have cold displacing warm. Remember, they're named for what does displacing. In this case, it's the cold. Take a look at this picture. We have cold air advancing. We have a warm air mass already there. The cold air forces the warm air to go up. This slope is usually really steep, and the warm air is forced up, and we have heavy precipitation. This down here, these cold impricules, as my preschool teacher would say, this is the symbol for a cold front. This website that's located up here is much like the lab that you did in class. It's going to look at warm water and cold water interacting with each other. If you'd like to see it, by all means, please just type that in www.youtube.com/watch?v equals W8OIDVVX8FK. Warm fronts. What's doing the replacing? The warm air. So take a look at this picture. We have advancing warm air. We have receding cold air. So we are moving from left to right. This advancing warm air is replacing the cold air. So the warm air mass is named because of the warm air doing the replacing. If you take a look at the slope, we have a nice gentle slope in comparison to what we had for the cold front. And here we're going to have widespread continuous precipitation. So those cloudy days where it just keeps raining. There are high clouds like the cirrus stratus. We also get some middle clouds like the altostratus that are going to form ahead of a warm front. See up here how it says cloud development from frontal lifting of warm moist air? It's slightly ahead of the actual front. Here is the symbol for the front. These nice half circles that are in red. That's going to be warm. So let's talk a little bit more about those clouds. They form in the air that is high above the cool air. So that's why we're going to get things like this cirrus. As the front passes over an area, the clouds become lower. That's how we get alto. So if you take a look here, these are the high up ones, like right around here, and then lower we're going to have down here. And there can be thunderstorms around the warm front if the air is unstable. Take a look back in your atmospheric stability if you want or need a refresher about unstable air. Now let's take a look at stationary fronts. Stationary, what does it mean? It's not moving. It is stationary. It's staying still. Take a look at the picture. The symbol for a stationary front is a mixture of the cold and the warm front symbol. We have the cold impricules for the cold and the nice warm happy semicircle for the warm. Notice that the arrows, the warm front might be moving along the border and the cold front might be moving along the border, but the border itself is not moving. That boundary is not moving. The two masses of air are pushing against each other, but neither one is powerful enough to move the other. Neither one is powerful enough to move the other. So winds are blowing parallel to the front instead of perpendicular. Remember that parallel is in the same direction, perpendicular is not. So winds are blowing parallel to the front. That's why it's not moving. It's going to stay still. And so what will often happen is that there's going to be differences in air temperature and wind on both sides. And that kind of makes sense. If we have warm on one side and cold on the other, there's going to be a temperature difference, but there's going to be wind because of those density differences that exist. And often it's going to be cloudy. There can be some rain or snow, but these are that continuous unmoving system of air. And if the front is in an area of low pressure, remember lows suck, they're going to continually to have that stationary front. So let's look at this monster, the occluded front, and the symbol is in purple, which I like because I like purple. But take a look at the difference. See the occluded front, it has both the triangle and the semicircle. Take a look back at the stationary front, it has the triangle and the semicircle. But what do you notice about them? There. 1, 2. 1, 2. Well, here they're going in the same direction and they're purple. So that's one huge giveaway. And occluded fronts, the fronts move faster, the warm fronts don't move as fast as the cold fronts. So it forms as the cold air behind the cold front meets the cold air ahead of the warm front. So take a look at this picture. Cold and dry air is moving in, and we have more cool air moving in this direction. So we have behind and in front there's cool air. So there's going to be precipitation along the occluded front, and the wind changes direction as the front passes. Take a look at these arrows. It's showing you how it's moving. And after the front passes, the sky usually clearer and the air is drier because it's all raining out on the occluded front. So those are our quick notes on fronts. You are now going to be able to do the back of your air mass wind worksheet that has the front table. Please feel free to use other resources to complete that sheet. And if you have questions, make sure you see me. Have a good one. Bye.